In this video we shall discuss how to acquire non-repeatable unique values. In the first task we have to write a query to get two non-repeatable random subscribers IDs. The expected result should look like this. We shall get a table with two columns, one row, and these two values should never be the same. Before we dive into the solution, let's look at the general idea. First, we have to get two sets of values with two values and one value. Here are those sets. Because we deal with primary keys, the set with two values is guaranteed to have two different values. Here they are. And then we have to create a Cartesian product of that two sets, and by definition it would contain at least one row with different values. That's what we need. You may see that while these two values are the same, these two values are not. One may ask, why don't we use these two different values, because we already have them. But the first idea is that we need those values in a row, not in a column. And the second idea is to demonstrate one typical mistake. We shall talk about that mistake in the second solution. Now let's proceed with SQL code, starting with MySQL. In the first query, we produce the first set with two values, for instance 5 and 7. In the second subquery, we produce the second set with one value. Imagine it's 9. Then we have to produce the Cartesian product for that sets, and the result will be the next in this particular case: 5, 7, 9, 9. And then we have to extract one row with non-equal values in the left column and the right column. Let it be this row, for instance. But what if we are not so lucky and this value is not 9 but 5? So the Cartesian product will be 5, 7, 5, 5. This row contains equal values 5 and 5, so we cannot use this row, but this row contains different values 7 and 5, and we can use this row. For Microsoft SQL Server, the idea is exactly the same. This first subquery produces the set of two values, and this second subquery produces the set of one value. Then we have to produce the Cartesian product of these sets, and the result will be the next. And then we only have to select one row where the first and the second value are not the same. And for Oracle the idea is the same. This subquery produces the set of two values, this subquery produces the set of one value, this cross-join operator produces the Cartesian product, and then we only have to select one single row with the first and the second values not equal to each other. In the second task, we have to write a query to get two non-repeatable random subscribers IDs, but using common table expressions. Obviously, the expected result here is the same as for the first task. In the solution for MySQL, we have to use two common table expressions. Here's the first, here's the second. The first common table expression produces a single value. Assume it's 17. The second common table expression also produces a single value. Imagine it's 19, but this single value should not be equal to the first value. And so we have two different values and we only have to cross-join them to get our final result. It should look like this: 17, 19. This solution may look simple, and for real it is for MySQL, but not for Microsoft SQL Server and Oracle. Please pay attention that this solution for Microsoft SQL Server is a wrong solution. Why is it wrong? Because in Microsoft SQL Server, common table expressions are not persistent. Their contents is recalculated on each call, so this attempt to get unique values is useless. Here how it works. Imagine that the first common table expression produces that 17 value. But this subquery activates another call of the first common table expression, so the value here will not be 17, it will be something other, like 19 for instance. So the value produced by the second common table expression is not related to the value produced by the first common table expression. And that's why we may easily get such a result as for instance 5 and 5, and that's prohibited by the task. And as we may see, the conclusion is rather sad here. This task has no solution in Microsoft SQL Server at all. With Oracle we have the same problem, because in this DBMS common table expressions are also non-persistent, this condition is useless. It means that if, for instance, the first common table expression produces 5, that 5 will not appear as the result of this subquery. This subquery will force the DBMS to recalculate the result of the first common table expression, and the result here may be any other result, for instance 3 or any other number. And finally, we risk to get such results as, for instance, 10 and 10, and that will violate the initial task. But unlike with Microsoft SQL Server, with Oracle there is a workaround. Yes, this solution works, but it's also dangerous. It's dangerous because it's a tricky, undocumented hack, and it may work perfectly forever, or it may stop working anytime. With these query hints, we are telling Oracle to make the results of these common table expressions materialized ones. That means that the results will be fixed. And once the first common table expression produces a number, 7 for instance, that 7 will remain in this subquery. That's why the second common table expression will produce any value except that 7. And finally we'll get the correct solution, 7 and 9 for instance. But once again, it's a dangerous approach. You may never rely on any undocumented feature of your DBMS.